I think the long like when I turned on my date goes through. Alright, that's what I figured. That's like that. What did they call? Okay, you're yes. It's like yeah. For you see I see.
Okay, if we can turn to page 4, Ernest, what's the question that you were asking about number 13? Okay, so let me walk through this one here. So this is number 13 on page 4. It says if a sub n, if the rule of sequence a sub n is greater than 0, it means positive, and then the limit as n approaches infinity of a sub n plus 1 over a sub n equals 2/3, which of the following series converge? So if I want to get a sub n plus 1 and a sub n to show up as a ratio, I'm going to use ratio test. So I'm going to apply ratio test for each of these. And then once I get that a sub n plus 1 and a sub n to show up, I'm going to replace that ratio with 2/3. So I'm going to go through ratio test setup for each of these. So 3 to the n. It will be 3 to n plus 1 times a sub n plus 1. So that's my a sub n plus 1 term divided by my original. This time I didn't do the reciprocal thing because I didn't have a fraction here. So I just divided by. And then I can reduce this 3 to be just 3 because the 3 to the n cancels out. And then now the a sub n plus 1 and a sub n, I can replace this with what's given to me, is 2/3. And then once I make that substitution, then I want to look to see what number I get. Is this, but this is still ratio test here. So I'm going to compare my result with 1. Is it less than 1, greater than 1, or equal to 1? Because it's greater than 1, it diverges. Okay. So we're looking for a converging series. So A is out. So let's look at part B. Part B, this is my a sub nth term. So my a sub n plus first term, just replace every n with n plus 1. This time it's a fraction. So dividing by my a sub n, the same thing I'm multiplying by the reciprocal. And once I have this, I'm just going to clean everything up, try to get the a sub n and a sub n plus 1 together, get the 2's together, reduce, and then replace. Now it's different. Now it's a sub n over a sub n plus 1. So because of that flipped relationship, I'm going to make that 3/2. Okay, so once I make that 3/2, then 2 times 3/2 is equal to 3. That's still greater than 1. It's still diverging. Okay, we keep going. We keep checking. Next one. This is my a sub nth term. So my a sub n plus first term is just a sub n plus 1 times 7/2 n plus 1 to the n plus 1. Take this divided by my a sub nth term. Clean up as I can, which is 7/2. And then a sub n plus 1 over a sub n. Again, that is going to be this will be 2/3 because now my a sub n plus 1 is up top. Reduce, I'm still getting a number greater than 1, so this still diverges. Let's look at the last one here. Last one, replace every n with n plus 1 to get to my a sub n plus first term. Divided by my a sub n, the same thing as multiplied by the reciprocal. Try to clean up as much as I can. I'm left with a 3 here. Sorry, I'm left with a 1/3 here. My a sub n plus 1 over a sub n is 2/3. 2/3 squared is 4/9 times 1/3 is 4/27. Now that's less than 1, so this converges. That makes sense. Okay. All right, any other questions? Pages 1 through 5. Yeah.
Could you go over 12?
Yeah. This one here.
Yeah.
So it says, which of the following is required to apply the integral test? So integral test has 3 conditions, and that 3 conditions is that it's positive, continuous, and decreasing. The 1 to infinity is just because we're starting at 1. That's why that indication is there, but it's really just positive, continuous, decreasing. Oh, okay. Versus yeah. So that's why decreasing and not increasing. So that's just part of our conditions for integral test. Any other questions? Pages 1 through 5. Okay, so today we're going to work on worksheet 2. I may pick out some problems if I see something that's unique from that we haven't seen yet from pages 1 through 5, but otherwise I want you guys to basically work through at your own pace and ask questions if you're stuck. you guys picked up another worksheet here. Now, this is just for additional practice. I'm not going to assign it for homework or classwork. But if you just need additional reps, then I have these worksheets available for you to practice with. The keys are attached, and there's 2 worksheets in here. Okay. Okay. And if you decide they want to come in for a help session, we can work through these problems if you'd like.
So for that, because these like cancel out. So
Yeah,
it's
basically they're
one.
yeah, they're basically the same degree.
Okay.
So
Oh,
like x squared,
I
x
heard this one. I guessed that, and it was right, but I don't understand why. It's C.
as opposed to what page is that? Oh, page 1.
Okay. Yeah.
So limit comparison test, we want to find a comparison partner, right?
Mhm.
Comparison partner just means that we want to take the cleaned up version, right? We know the n squared is basically not going to matter. So my comparison partner, which is that.
Okay. Okay.
Now, if it was something that I can reduce, if it was like n, n squared over n to the 4th, then I'll reduce it to be, to be 1 over n squared. That's my.
Okay.
But if I can't reduce, then that's my.
Okay. I just wasn't sure if I could like ignore the n squared.
You can, because it's a lower degree, so
Yeah.
it's like a lower degree, you're gonna get a lower degree.
I see.
Oh, I subtracted, I divided. So.
It's just gonna be a yes. It's not geometry. We just like plug in here and like see what's gonna happen. Yeah, this one I haven't quite gone over this telescoping series. So what happens is we have these terms that are staggered. And so every term that shows up is going to end up being subtracted. So ends up all the terms ends up canceling each other out. It's just down to just one. So it's kind of a good thing to know that it's not necessarily something that will be on the test. Yeah, so we call this telescoping series because show you real quick what the pattern is. Maybe I'll go over it. So if I plugged in, if I plugged in 1, then 2, then 3, then 4, we're going to see that every other term, after the first term, every term is going to start canceling out. So if it goes to infinity, technically all the other terms will cancel out, except for the first term.
And even if I didn't recognize that, like if I just had approved converters, you can still do it like that, right?
Yes, but the telescoping series allows us to actually find the sum. So we're actually able to find the sum just by testing out the path.
And also then you do I just like space, you know, I can.
Okay. Sounds good. Okay.
So it's negative 2 go away, like that's it. It would just be like 1/7, right?
Because at -2 is such a small value, 7 to the n is gonna take precedence. So it's in favor. It's like Um,
Do service as well.
they do, but hold on, let me just show you page 8. So we write it this way. Imagine, um, imagine a problem that was written this way, and that's 7 versus infinity of 7 and squared over 49 and squared minus 2. What's the limit of separation? Just 7 or 49, because that we only care about the highest degree. So think of 7 over n as higher degree than the constant, that's why.
It's true. I forget the way you can tell if it's like if you should do root test or not for problem inputs.
So, yeah. So root test, we can't do it because the b squared is staying out here.
Okay, so that's a
So,
part of it.
Yeah, the b squared is part of it, and it's not, you can't raise to the nth power, so.
Okay.
We just want to use geometric series for that. Yeah, plug the endpoints and then see which one has alternate series. Yeah.
for that one. Like, I'll talk about that because I felt absolutely done right there. But the answer case I had between 0 and 7.
Yes, it is between -7 and 7, but then we have that additional restriction, so that's why. Otherwise, you'll be right. So, okay, what we should always be doing is for ratio test, we should always put absolute value because we want to guarantee this can be a positive number. So that way we're always comparing with a positive number.
Anytime I do ratio tests.
Yeah, always put absolute value. Just always do that. Yeah.
Mhm.
It's on the same problem.
Right.
Yeah, so what happens is this x squared and zero, and we could use zero, so.
Otherwise, you would be right.
So it is, you did it by p-test, p-test. Alright.
P series.
So I do it by nth term, just take the limit to infinity of that.
Now remember nth term, you're comparing with zero, right? If it's approaching zero, it's inconclusive. If it doesn't equal to zero, then we say divergence. But nth term,
But if it equals zero, I can't say that it converges.
yeah, cannot.
Okay.
Nth term is only a test for divergence. Yeah.
Question about number 13, I mean, number 16, on page 13. So. You see, this says that it converges if p is greater than 3, but since it's the absolute value of r must be less than 1, wouldn't this also be p, and it should be less than negative?
Like -4.
Like how, because if it's -4, would that still work? Because the absolute value of r is going to be less than. That would still need the condition that p is less than 4, so it would not just be this, and then p is less than 3.
I think you make the point there. Let me look at it further. Okay, so that's not. If that's the case, then you would say between 3 and 4, and if p is less than -3. You may have something there. Let me look at it somewhere. Thanks. Evan, I think you're right, but that would feel a little too tricky. So I think the problem should have been rewritten as for what positive values of p for both, because technically you're right, you can go to the negative side, but I don't think that fits the complexity of what we're supposed to do. But thanks for that catch, though.
Okay, thank you.
Okay, so tomorrow I'm gonna be checking your homework for worksheet 2. And I'll have help session tomorrow morning and tomorrow afternoon. If you feel like you need some additional support with these problems. Okay, and I'll go over some problems on worksheet 2 before we do worksheet 3 tomorrow in class. All right, come get your phones. I'll just. Oh, essential. We're working on it. So,
Yes. They become easy.
On check.
Then you get.
It said you can converging, but my inline limit doesn't equal zero, so then it's not converging.
Yeah.
And there's it is.
yeah, I meant to say that. Thanks for that. Appreciate it.
Hey.
Yeah, but. Honestly, look.
You are going to.
I'm gonna do it tomorrow. Because like.
It's like the. It's so.
One test the far out.